If you find it hard to understand fibrous dysplasia from the textbook, then this video is for you.
Fibrous dysplasia?
Fibrous dysplasia.
Fibrous dysplasia.
But today, you don't even have to open your textbooks because I've compiled all the important points from this textbook into this one video so that you can keep your books closed. But that's not all. By the end of this video, I will be giving you my complete notes on this topic for absolutely free. By the way, I'm Bleston and I'm a third year dental student. So here's our plan for this video: etiology, classification, clinical features, radiographic features, histopathology, differential diagnosis, treatment, and prognosis. Let's start with the etiology. This is chromosome number 20. Now, there's a gene called GNAS1 located in it. This gene is responsible for producing G protein. In a normal person, when G protein is activated by some hormone or growth factor, this G protein turns on like a switch and forms cyclic AMP. Once the activation is stopped, the G protein turns off and stops producing cyclic AMP. But in fibrous dysplasia, there happens to be a post-zygotic somatic mutation in the GNAS1 gene. To make this term easier, let me explain this to you in 3 points. Number 1, this mutation occurs post-fertilization, that is, after the formation of zygote. Number 2, only the mutated cell and the cell that grows from it will have the mutation. The rest of the body's cells will remain normal. Number 3, because the mutation happens in a somatic cell and not a germ cell like sperm or egg, this mutation cannot be passed down to offsprings. So, the G protein now formed from this mutated GNAS1 gene does not require any form of activation. It just goes on and keeps producing a lot of cyclic AMP. So, we will look into 3 major systems where this excess amount of cyclic AMP causes problems: the bone, the skin, and the endocrine glands. Firstly, we'll look into bone. There are 2 things that occur majorly. Number 1, maturity arrest. Normally, mesenchymal stem cells are the ones which will convert into preosteoblasts and then finally into osteoblasts. But due to excess cyclic AMP, they get stuck at preosteoblastic stage and produce fibrous tissue instead of bone. The second one, WNT disruption. WNT pathway protects beta catenin as it is the one which instructs the cell to mature and produce mature bone. But due to excessive cyclic AMP levels, this WNT pathway gets disrupted and beta catenin is destroyed. Therefore, the bone which is produced is weak and improper. As a result of these both mechanisms, osteoblastic maturation and formation of mature bone is affected. And this is literally what fibrous dysplasia means. Normal bone tissue is being replaced by abnormal fibrous tissue. Number 2, skin. Excessive CAMP will stimulate the melanocytes present in the skin to produce excessive amounts of melanin, leading to hyperpigmentation, which we call as cafeolite spots. The key features of these lesions: 1, they do not cross the midline. Number 2, it has irregular margins. Number 3, endocrine glands. Due to excessive cyclic AMP, ovaries produce excess estrogen, leading to precocious puberty. Likewise, hyperthyroidism, acromegaly, and Cushing syndrome. At what level the disease affects depends entirely on when this mutation happens. If the mutation occurs early in an embryonic development, it affects multiple tissues: bone, skin, endocrine glands, etc. If it happens late, it might just affect a single bone. Now we'll look into the classification: monostotic, polyostotic, and syndromic. Monostotic occurs in 70 to 80% of the cases. Only a single bone is involved. If maxilla and other associated bones are affected, there happens to be leontiasis ossea, also known as lion-like face. Polyostotic occurs in 20 to 30% of the cases. Two or more bones are affected. If multiple craniofacial bones are alone involved, it is called craniofacial fibrous dysplasia. Syndromic, there are three main syndromes that you'd have to remember. Jaffe, which is a combination of polyostotic fibrous dysplasia and cafe or light spots. Number two, McCune-Albright syndrome, which consists of polyostotic fibrous dysplasia, cafe or light spots, and endocrine dysfunction. Number three, Mazabrod syndrome. It comprises of fibrous dysplasia and intramuscular myxomas. Moving on to the clinical features. Oral and maxillofacial features. Slow, painless, and bony heart swelling, which is usually unilateral. Malocclusion. Skeletal features are shepherd's crook deformity, which is a pathognomonic feature of polyostotic fibrous dysplasia, where femur undergoes repeated microfractures and remodeling. And pathological fractures, dermatological features, cafe or light spots, the endocrine features, precocious puberty, hyperthyroidism, acromegaly, and Cushing syndrome. Moving on to the radiological features, ground glass or orange peel in mature lesion, ill-defined borders, Rhine sign, which is external sclerosis around the lesion. Coming to the histopathological features, Chinese letter pattern due to the formation of weak and abnormal bone. There is no osteoblastic rimming, which means around the lesion there is no osteoblasts seen. The main differential diagnosis is ossifying fibroma. Comparing this with fibrous dysplasia, ossifying fibroma has well defined borders, it has osteoblastic rimming present, and there is persistent growth. The treatment and prognosis. Fibrous dysplasia is usually self limiting. It generally stops growing when the patient reaches puberty. So, we stick to cosmetic treatments later in life. But listen to me closely. Never use radiotherapy. Radiation dramatically increases the risk of malignant transformation into osteosarcoma or fibrosarcoma. And as promised, the link to my notes are down in the description. See you in the next one.